Welcome back. I'm continuing with my exam 2 practice problems, running through the solutions. In this particular video, I'll work through 7 through 11. So if you don't have any questions on these, maybe you skip to the next video. But anyway, let me pick up with number 7 here. I need my pen. Okay. So in number 7, they ask us to do something that we do a lot in calculus, which is we're trying to find the equation of the line tangent to a function. So our answer is going to be a linear equation, like a y equals mx plus b. And so the way we're going to find this equation is we'll use the point and we'll find the slope using the derivative. So I'm going to start that question right up here for number 7. First of all, I need my derivative because I need that to get the slope. So the derivative here, we can just use our power rules on the terms. This is going to be 6x squared minus 6x, and then the derivative of negative 5 is 0. So there's my derivative. Now notice the point is 2 comma negative 1. So they're telling me that my x-coordinate is 2 and my y-coordinate is negative 1, where this line is going to bump up next to my curve. So to get the slope here, I just need to plug that x-coordinate into my derivative. So I'm going to plug in a 2. And then basically I just do 6 times 2 squared, which is 6 times 4, minus 6 times 2. And that will be my slope. Let's make sure I don't mess this up. Let's see. I believe that's going to be 24 minus 12, which is 12. So the slope is 12. Now, what we do from here is we use our point slope form for the equation of a line. So I'm going to start out with y minus, and then I'm going to write that y coordinate in there. That's a negative 1. So that's like a y plus 1 equals, and then my slope, we'll write that in, that was 12. And then times x minus the x coordinate, which was a 2. So basically I filled in the green, the red, and the black into the point slope form. And frankly, if you're a little shaky on your algebra, you can just stop right there. Most people like to see it in the more traditional slope-intercept form, so I'm going to finish this one off. But if you're in a hurry or if you're a little worried about your algebra, you can stop there because you've done what I asked you to do. Now, to finish this off, after I get my little pen out of the way here, so I said this was like y plus 1 equals, and then I can distribute that 12. So this is 12x minus 24. And then all I'll do is just subtract 1 from both sides here. And if you're wanting to see this in the more traditional slope-intercept form, you do y equals 12x minus 25. And that's also a perfectly acceptable answer. We'll highlight that one in green just to give it a little bit different color. But that's our number 7. So this is the first question where we really had sort of a multi-step situation. I had to find the slope first using the derivative, and then from there I used my linear equations and algebra to finish this thing off. Okay, back to some calculus and some derivatives here. In number 8, which I guess I'll do here in this little spot. I accidentally switched it to an eraser, sorry about that. In number 8, we're asked to use the product rule to find the derivative of this product. So typically the way I do this is I get organized first. So I break my two factors into what we call u and v. So that would be the u as 7x plus 2. So this guy right here is the u. And then the derivative of u is 7. And for v, that would be the 3x minus 8. V is 3x minus 8. And the derivative there would be 3. Once you have those pieces, you can put that into your product rule formula. I think the way I explained it in one of my videos was v times u prime plus u times v prime. But there's different versions that are just basically showing you that if you cross multiply these two things and then add them together, that's the derivative. Okay, so here's what ours would look like. F prime of x, which is our derivative, we're going to do the 7 times the 3x plus minus 8. and then the plus sign in that formula, right? We're adding those two products together. That would be 3 times 7x plus 2. And that is the derivative, okay? But what we're going to do is we're going to use our, algebra skills to simplify this thing a little bit. But that's one version of the derivative. Let's go ahead and clean this up. We call this simplifying. And what I'll do is just distribute and combine like terms. So the answer that we're usually looking for looks like this. This is 21x minus 8 times 7 is 56. And then 3 times 7 is 21, so that's 21x also. And that's plus 6. And when you simplify that, you have, what is this, 42x minus 50. So that derivative turns out to be a linear function, and the simplified version of the answer is 42x minus 50 there, okay? In number 9, we're going to do the quotient rule. And so I'm going to set this up a little bit, and then I'm going to slide my screen and work down here in the corner, and I'll give myself some free space. But essentially, we start this process the same way. My numerator is I like to call that red here. So let's, the numerator is our u, and the denominator is our v. Now these u's and v's, they're not actual calculus. These are just tools that we're using to get organized. We're using some algebra to get us organized so that we can run through that quotient rule. So in our case, if I'm working on number 8 down here, my u is x cubed minus 5. And the derivative of that is 3x squared. And my v is x squared plus 6. And that means my v prime is 2x. And then your quotient rule, remember, is vu prime minus uv prime over v squared. And so I'm just going to use this little organization that I made here to start writing that out. So my derivative is going to be v times u prime. So that's these two, vu prime. So it's going to be 3x squared times x squared plus 6. We do the bottom one times the derivative of the top. Then there's a minus sign. And then it's going to be u times v prime. So that's going to be 2x times x cubed minus 5. And the whole thing is over v squared. Now, here's my recommendation to you. We are going to simplify the numerator, but don't mess with the denominator. Just write the expression squared and leave it alone. Almost always multiplying that out doesn't help us, so we'll leave it like it is there. However, in the numerator, let's go ahead and clean this up a little bit. So we'll distribute and then combine like terms like we did with the product rule. And just be careful with your exponents. So this is going to be 3x to the 4th plus 18x squared. And here's where you need to be extra careful. This minus sign gets distributed with the 2x. So as I write this out, I need to make sure I multiply by negative 2x. So that's going to be negative 2x to the 4th, because it's 2x times x cubed, and then plus 10x, because negative 2x times negative 5 is positive 10x. Don't mess with the denominator. You're better off just leaving it as x squared plus 6 squared. Now we've got that set up, and then we can go ahead and just combine some like terms on the top here in the numerator. So my final answer that I would probably write would be 3x to the 4th minus 2x to the 4th. That's just x to the 4th. And then I've got the plus 18x squared and the plus 10x. That's all that's left in the numerator when I combine like terms, and then again, just leave the x squared plus 6 down there. Squared, obviously. Okay, hopefully that's obvious. Anyway, let's highlight this, and we'll call that our answer. Same one that I have in my written answer keys. Okay, so that's 7, 8, and 9, and then we got to do 10 and 11. These are going to be a little faster, but I just need to make sure I gave myself enough room. Okay, So I'm going to rewrite number 10, and then this is 9, sorry. I'll rewrite number 10 since it's about to go off the screen, and then we will work through it. So it's the original function is 4 times the quantity x squared plus 6x cubed. So that whole thing cubed. This is number 10. And essentially what we're going to use is our chain rule, also known as the general power rule. Okay, so just be careful when you're working through this. And I have a phrase, which is don't forget the doggone chain rule. That happens a lot with students. They do half the derivative and then stop. So let's be careful as we work our way through this. We can do it all in one line. We just need to be careful. So the first thing we're going to do is we're going to deal with this exponent here. And as you know, when you're doing a power rule, you bring it down and you multiply it by the 4. So this is going to be 12 times the quantity. And then this is important. Don't mess with the x squared plus 6x. We're not messing with that right now. We do mess with the exponent though, so that becomes squared. So now we have 12 x squared plus 6x raised to the second power. Once you're done with that, then make sure you multiply by the derivative of that green stuff. The derivative of x squared plus 6x is 2x plus 6. Don't forget that thing. And once you've done that, that's our chain rule. That green stuff is our chain rule. Please just stop, right? You've got the derivative there. It's all good. I mean, if you wanted, I suppose you could move a couple of these terms around, but don't try and distribute that 12 in this squared product here. You're not allowed to do that. It's just, you're better off leaving it like this. This is a perfect answer. Sometimes the more algebra you do, the more trouble you get into, and we don't want to have that happen. Okay, and then number 11. So number 11, let's just go back here and look at it. Sorry, I'm not trying to do this too quickly. Has a little hint here. We're going to use that chain rule, but my hint is to change the radical back to an exponent first. And we did that in the previous problem as well. So let me slide down here so I can do this. So I'm going to rewrite that function for number 11. Instead of the radical, I'll go ahead and write what they had there, or what I wrote it, so I guess I should write what I had. Square root of 3x squared minus 11x. So that's the original function. Our hint said to rewrite it using exponents instead. So if I rewrite this thing, it's still 3x squared minus 11x, but the whole quantity is raised to the 1/2 power. Remember, a square root symbol, which we call a radical, is the same as an exponent of 1/2, or to the power of 1/2. Once we have this here, let me just move this down a little bit, get it out of the way. Oops, jeepers. That was a little radical, a little crazy. Okay. Once we have that there, we can just go ahead and run through our general power rule, which is basically the power rule plus the chain rule. So my derivative starts out with bringing that 1/2 down. And remember what I said, do not mess with that stuff in parentheses right now. It's still 3x squared minus 11x. I'm putting it in a different color just so you can see that I didn't mess with it. I do have to mess with that exponent though. You have to do 1/2 minus 1, which is negative 1/2. Don't forget that. And then just like the previous question, we have to follow the chain rule before we're done. So I have to multiply by the derivative of that green stuff, which is going to be 6x minus 11. Okay? Now, if you want to stop here with that solution, you're welcome to do that. Since it was written in radical form, a lot of times you will see people put it back into radical form. And so I'll kind of show you how that ends up going here. Because this quantity is raised to the negative 1/2, it ends up in a denominator with that 2. Okay, so on the bottom here, I do have 3x squared minus 11x raised to the positive 1/2 power. I'm going to put this under a radical because that's how we write it when it's 1/2 exponent. And then this part here ends up in the numerator, 6x minus 11. Now, if that 11 was an even number, I could do some more simplifying, but because it isn't, we're kind of stuck here. This is as far as we can go. Okay, so if you want to get it into radical form, you can use that solution. The one in yellow is perfectly fine. You followed the general power rule, which we also call the chain rule. I'm just going to zoom back out here a little bit and make sure I answered all the questions that I intended to answer. Yes, I was going to do 7 through 11, and we've done that. And all of these solutions match the written ones that I posted. So you already have a copy of these if you want to look at them, but I wanted to talk you through these just in case there were any issues. I'm going to stop here, and then I'll start with number 12 in the next video. In the meantime, take care.